Hey, folks,
Right.
here we are.
Hello,
Welcome
hello
to
everyone.
welcome to episode 174, where we're gonna switch things up a little. So,
Yep.
but yeah, we're gonna before switching things up, we will take it to the usual route. We'll share a little Quarkus news. The mom will give us the overview of past week or so, and then we'll get on with our special guest.
Yeah. So yes, today the host is Georgios, the official host is Georgios. I'm just here because I'm interested by the subject. It's PTO season, so that's why we are shuffling a little bit the team. So in the news, so first we got Quarkus 3.12.3 released on July 17th, so last Wednesday. And if you are using 3.12, we highly recommend you to update to that version, containing a set of bug fixes, nice stuff around TLS and stuff like that. The other big news is that we announced which version will be the next Quarkus LTS, and it's going to be 3.15. We will do like last time, so we are going to do a 3.14 in August, and that is going to be a fork of that one. And then main will go directly from 3.14 to 3.16, while 3.15 will be the continuation of 3.14. And if what I just say looks completely weird, there is a blog post. So thank you, Georgios, to share the blog post because that's basically playing with version to ensure we have enough hardening time to make the LTS really an LTS. There's plenty of cool things in that LTS. So if you're only updating from LTS to another one, strongly recommend it once it's out. So we plan to release it in September-ish. Probably September-ish. All right, but now let's go to the topic of the day. Today we have a special guest, Charlie. Charlie has been using Quarkus for a couple of years now, and in a very interesting domain that we don't often see Quarkus there. And he came with very strong requirement in terms of performances and response time. And our interaction with Charlie has been very interesting, and so he proposed himself to come here and present. So, Charlie, let's introduce yourself, and yes, that is yours.
Hey everybody, yeah, I'm Charlie Dennison, software engineer. Really good to be here. Thanks for having me on the show. I'll jump right into it. I have some slides to help keep me on track, remind me all the wonderful things I want to say about Quarkus, and we'll just get into it.
Wonderful and not so wonderful. It can't all be great.
Yeah, well, we'll save the bad stuff for the end when most people have stopped watching. So, a little bit about myself. So actually, I started off wanting to do embedded development, ended up getting into manufacturing automation of all things, and kind of all the data analytics around that. Now I'm working in the Internet of Things space related to 5G edge and other domains. I've used a lot of different languages and deployed in a lot of different environments. So I definitely feel like my career has been a little bit all over the place. I don't know if that's good or bad, but people have told me I don't have a typical perspective on things. Maybe just because I've done too much, or I'm not sure. But I do feel like I should admit at the beginning, just come clean and confess that I don't actually like coding in Java. I don't know if that's surprising. Actually, most languages I haven't particularly enjoyed, except for Python. But I do have high hopes for Kotlin, so I want to mention that I'm hoping that'll change my perspective on the JVM.
And we have support for it in Quarkus, right?
Kotlin yes, support. But there were some issues, so we'll talk about that. Mm-hmm. So, but yeah, and in terms of environments, I mean, a lot of the talk today is about deploying in different environments. So I've been all over the place: cloud, edge, embedded, desktop, mobile, and of course, I have to give a shout out to Lego robots. That's my favorite. And also the favorite of my two daughters, Ruby and Rissy, they love the Lego robots. So, thank goodness there's one environment out there that's fun to deploy to. And then, the last thing, so kind of why I'm doing this talk, I'm actually leaving my job. So I'm actually ending my time using Quarkus, most likely, because at least in my interviewing process, I'm not seeing Quarkus pop up. I can't say I've seen it pop up one time. So yeah, this is a little bit of a retrospective, I guess, thinking back on several years of using it, kind of what went well, what didn't. So I guess, yeah, in some ways it's about my own professional development, but hopefully it helps other people as well to kind of do this kind of retrospective. So that's the goal. So it's kind of a rambly, yeah, go ahead.
That's a very unique perspective that we're really glad to have here. Yeah, we haven't actually had that kind of thing. Usually it's people that have started out using Quarkus or they've been using for a few months or things like that. So yeah, this kind of thing, that looking back at the whole journey, I think it'll be great. Yeah.
Cool. Yeah, so just keep that in mind. This isn't like a technical presentation where I'm trying to convince people or defend some position. I'm just kind of storytelling, trying to share my struggles. Hopefully maybe you'll get some questions answered. So yeah, probably a little bit different than what I would normally do when talking about. Normally Quarkus, I'm very technical, but this is just kind of, yeah, a little bit behind the scenes. So anyway, so yeah, jumping into my use case, just to kind of get right into it. So I wanted to talk about two environments I've deployed in recently, where sort of 5G edge compute plays a role. Before getting to that, though, I thought I'd just describe the environments first, because sometimes people just get lost. You start talking 5G, they're already bored. So two environments. One is I deployed, kind of large, REST API backend application in a public cloud. I think a typical public cloud deployment is, kind of like, at least for US-based, audiences, like an East and a West deployment, and, CDN for static assets for, web, mobile, things like that. So one area where 5G edge compute helps is with network latency. So I'll talk more about that on the next slide, but just kind of throwing out some numbers. Again, this isn't super rigorous, but I think typical latencies for like a REST API would be network latencies. End to end would be 1 to 200 milliseconds for like a public cloud anywhere in the US. And a CDN is, yeah, go ahead.
And just to clarify, you're in the US, right?
Yeah. This is I'm just talking US. Yeah, I don't really know about. I mean, I know AWS and things like that are global, obviously, but I'll just confine my comments to the US.
Yeah, excellent. Yeah, so that's cool. That's cool. Just so everybody's on the same page here. Cool.
Yeah. So a typical US deployment, I'm thinking, it's kind of like 2 data center, east-west. And then if you do that, the idea is anywhere within the US. I did some research on these numbers, right? So if you have 2 data centers in the US, anywhere in the US, you should be around that 100 to 200 millisecond number. That's kind of what that gets you, 2 data center deployment. And again, if you go with most CDNs, I think you'll get the sub 10 milliseconds because there's a lot more CDN locations, obviously, than 2. But yeah, so if you need to do better than that, 5G edge compute is an option. That's kind of what I'm going to say on the next slide. So that's kind of one scenario, the public cloud. The other one is more, you could call it private cloud, private network, private on-premise, something like that. So this is something I did where actually I had to get an environment working in Taiwan, of all places, so in a factory. So like I said, I've been kind of all over the place, but I can tell you that it was a real nightmare to find an ISP, do the local networking, buy physical servers, ship them there, install them, set them up, connect them to the cloud, connect them to the manufacturing equipment. Not something you want to have to deal with, I can assure you. So this is another area where 5G edge compute actually really helps. So I figured I'd try to cover these two scenarios just to give people a feel of why this matters. But yeah, any questions so far on this first slide?
Well, I was just going to say that I'm pretty sure that most folks that have watched this show are familiar with the first scenario. I'm pretty sure like almost nobody's going to be familiar with the second scenario, right?
Yeah.
That was a super interesting use case. We have heard of some similar stuff, but definitely not like as difficult as you described, where you have to go through this whole ringer of setting stuff up, right? So this is cool.
Yeah, well, I'm pretty sure it's also pretty painful, even if you're in a private cloud in the US. I mean, it's not easy to necessarily add a server. I mean, there tends to be a lot of red tape, especially big enterprises. But yeah, I think it'll make sense, kind of, where 5G fits in. But cool, yeah. So let me go to the next, next little more detail on 5G edge compute. So I'm not going to talk much about this. I have one slide honestly, my experience is sometimes you start talking 5G, everybody tunes out and thinks it's boring. So I guess maybe just because there's other topics that are much more interesting right now in the news or whatever. But yeah, so basically the way I think about it is it's just new environments where you can run your code. That's really all it is, right? So I don't know what it was 20 years ago, 30 years ago, and basically you're running it on-prem. Then there was cloud, and now there's kind of this new place, which is 5G Edge. So basically the way it works is, if you need better, say, latency than what I was talking about with, say, that east-west type of scenario, you can actually run your code, whether that's a Quarkus, microservice, whatever it is, right? You can run it at the network edge, which basically means most telcos, the big telcos, at least in the US, they actually have like little mini data centers in all 50 states, typically like in the capitals, whatever. So part of 5G is actually, without getting too much into the details, it's a way for you to be able to deploy your code to any of those data centers. So you can now run stuff very close to potentially your devices, your users, or whatever. You can achieve very low latencies. There's other reasons to do it. Some people are doing it for privacy. Sometimes it's more of a bandwidth issue. But it's actually very easy because you can actually use your favorite cloud provider in most cases. Like if you're using AWS in the cloud, you can actually use AWS and push your application to the 5G edge using the same tools, literally, if you have like a CI/CD, you can just add like another parameter, and bam, there it is. I mean, it's not quite that simple, but that's sort of the promise. And so for the private cloud case, it's actually the same thing. So again, I'm talking in very high level. I'm not trying to make promises and sound like a sales guy, but yeah. So, when you set up a private 5G network in a factory or something like that, I don't think you have a choice. You're going to get edge compute as part of that. Probably you're going to be asked to check a box. Do you want AWS, Azure, something like that? You're going to check that box, and probably you're going to have, almost guaranteed, you're going to have an option to push workloads to that private infrastructure. And again, using the same tools you would use in the public cloud. So I don't know if that makes sense. I know maybe it's a novel idea, but the idea is it's very easy now to run things like Quarkus in these new places and achieve much different performance possibilities.
So one thing I really like in what you said is, 5G is faster, but one of the key elements of 5G is basically we have moved part of the business code of your application closer to you. That's why it's so much faster sometimes, because it's actually next door. While otherwise, it's what you say, it would have been 200 milliseconds to go back and forth from one side of the US to the other side. So it's actually funny how now we have millions of data centers, probably even more, I don't know, which are actually at the edge of the network, and you can deploy your code there directly. That's super interesting.
Yeah, I was just gonna say, like, I don't know what crowds you talk to that find this stuff boring, but for me, who's like who doesn't have like this network and this telecommunications background, no, this sounds excellent. I mean, this is like the high level overview that I didn't even know, and this is amazing.
All right, good. Well, I'm glad I got two people enthusiastic. So I think the reason this is relevant to people is, it seems like there's a trend. Maybe it's slow moving, but I think probably more and more people will be asked, how can I achieve better performance? And they won't be able to say, well, I can't because there's this network latency that just bottlenecks everything. That's no longer an excuse. And even running stuff more like in the private cloud, again, the excuse in the past might have been, that'll never happen. There's so much red tape. You'll never stand up an application in a factory. I can assure you, people don't want you running Quarkus in their factory. Like, that's the default position, right? That makes people very nervous. But now we sort of address some of that. You can have your own private network for the Quarkus application. It can be all very well professionally managed. You can make sure that you can't accidentally, turn off the machinery, things like that. So a lot of those excuses, I think, go away. And so hopefully, there's new possibilities. So I'll just mention again. So the reason latency is related is that as you move from cloud to edge, and I'm going to even kind of talk about embedded, it's going to cost more money. That's probably obvious to people, but it costs quite a bit more money. especially if you want to set up a private, 5G network in your factory. That's a lot of money. So you're not going to go through all that trouble, pay all this money, set up this whole thing, and then you don't want to hear from the application developer or platform developer, oh, sorry, we can't actually take advantage of that performance because now the bottleneck is, Spring Boot. That's not what somebody wants to hear, right? So that's why latency matters, performance matters, because it's kind of like it matters where the bottleneck is, right? And we're kind of shifting the bottleneck potentially in these scenarios actually onto the application developer, which is kind of a new thing. So yeah, and the thing I'll mention about embedded, I don't know if I should call it embedded or not, but this is another kind of interesting trend that I've observed, which is, again, in these private networks and factories and things like that, you can probably imagine there's a lot of switching equipment, a lot of high-end networking equipment. So it turns out that this stuff's very expensive. I actually bought one for my lab. It cost $50,000 for one switch. And it turns out these are very powerful computers. I mean, they're servers. And you can actually now run workloads on these switches using Docker. It seems like they've kind of normalized on this. So you can push your Quarkus application to a Docker registry somewhere, and then basically with a click of a button, it's running on an actual switch. If you want to talk about the edge of the network, I mean, that's even closer. But again, more expensive, even more resource constrained. Probably they're expecting even better performance. So I think it's an interesting thing. Maybe it doesn't matter to Quarkus. I'm not sure, but I did explore it, so I thought I'd mention it. And then I'll mention just one last thing. So my area of expertise, I guess you could say, is 5G edge compute, but it's actually bigger than that. So if you look at just AWS, for example, AWS has a 5G edge compute option called Wavelength. They also have something called local zones, which honestly I don't know much about, but it's basically a similar idea. You can target an area of the country and say, I want to deploy my application to that area, and they can get it there for you at a lower latency and obviously higher cost. So there's actually ways to localize your application even beyond 5G edge. They also have a product called Outpost, which is actually a physical server that you can buy. I don't know if it's from them or from a partner, but you can actually basically put AWS in your factory through a very easy process of just like literally you buy the server, plop it down, and now you've got a private cloud in your factory. So there's a lot of activity in this space. I don't want to say it's just 5G edge. There's a lot of ways people, I think, are going to be running these kind of high performance, low latency workloads in the future.
That's awesome. I mean, this is like mostly new to me. So that's awesome to hear.
Well, I remember the time where Akamai was starting and pushing the same ideas, moving things closer to you. But yeah, this is a next scale. Like soon we will have our own Amazon cloud in our house. Like, well, might be a bit expensive. So
well, maybe not. I don't know. I mean, I guess you'd be surprised. But yeah, no, actually, and that's true. The CDNs, like I know Cloudflare, Akamai, they have their own flavor of this. So yeah, it really seems to be across the board.
And before we move on, we have Douglas mentions that he says it might be a little hard for him to ask you Java questions since you said you didn't like Java, we prefer Python. But yeah, I mean, I think we can welcome all questions, whether we like the stack or not. I mean, I think we can all agree that we don't like JavaScript, so that's a good place to start.
I mean, I say that a little bit tongue-in-cheek. Yeah, obviously, I mean, I've used Java extensively for many years. So, I guess I've just, and I was going to talk about actually how Quarkus is sort of the best of Java. That's kind of a sneak preview. So,
and Douglas followed up here, and he's saying that he doesn't have any motivation to go to Spring because he likes Quarkus so much, but there's so many Spring jobs, like you mentioned earlier. When you were doing your interviews and stuff like that. But yeah, I mean, we get that, and it makes sense. Like, yeah, obviously Spring is the king currently, but like Quarkus has come a very long way from like 5 years ago, right? So and we see that trends continue to go upward. So hopefully, things will even just get better. But yeah, I mean, that's how the industry is. So.
Yep.
Okay, so
Keep going here, or you got another question? Or
we have
comment?
one more. We have one more actually. Vincent says, "You mean complete circle? Like if cloud moved from computers owned by other people to computers owned by you?" Nice turn. Okay, yeah.
That's true. That's true. Actually, yes, yes. Before we,
Yeah.
we define the cloud about someone else's computer that you can use, but now if that computer is inside your home, maybe it's not. Yeah.
Yeah. So I just want to mention here that for me, like the real like upside is what Charlie mentioned earlier, that right you can use the same tools that the cloud provider has regardless of like where you're deploying and stuff like that. For me, that's like the real power, not that like you're just not managing a server or anything like that, because in a lot of cases you do want to manage it. Anyway.
Yep.
So yeah, let's move on if you like.
All right, I'll keep going. All right, so I want to get into kind of a more low-level technical scenario to really highlight the type of problem I was trying to solve. I'm not able to talk about the actual use cases I worked on. So this is a completely made-up use case. Maybe it's a terrible use case. I'm not sure. Maybe if someone's actually worked in this space, I mean, you can let me know. But yeah, I think it highlights sort of the performance, the way I thought about performance, because probably you guys know, I mean, a lot of people think about performance in this kind of very narrow way, like around like tech and power, HTTP request to database. I mean, that wasn't my use case. I mean, there was some of that. But my use case is more like this. So you can imagine something like a factory, maybe a busy downtown area. There's a bunch of things moving around. You don't want them to collide with each other. Nobody likes collisions between forklifts and robots and things like that. So you can imagine there's some latency requirement to monitor where things are and maybe issue a stop command to some API. And so I wanted to break the numbers down because it's often people can't really visualize why the throughput is what it is, why the latency is what it is. So in this case, you can imagine you want some kind of end-to-end latency, say 50 milliseconds. And so the way that one way this breaks down, again, these are made up numbers, right? But basically you can imagine if everything in an area sends its location every 10 milliseconds, if it takes 10 milliseconds to process those events, there's 10 milliseconds of network latency. You get, if I did my math right, 20 milliseconds in, 20 milliseconds out. Your worst case scenario is, thing one at T0, thing two at 10 milliseconds, 40 milliseconds total to process that. You get 50 milliseconds of, end-to-end latency. Now, the key thing here is if you're sending events every 10 milliseconds, your throughput, if I did the math right, is 100 events per second. If anyone wants to check that. So even for a small number of things, 100 things, that's 10K events per second. Obviously, you can imagine a factory with more things than that. I mean, I don't know how many cars there are driving around New York City. I wouldn't be surprised if it was more than 10K cars, So that's how you get these kind of high throughput, low latency scenarios. So a lot of people do performance testing, either looking at high throughput or low latency, not both. That tends to be a particularly nasty challenge. I'll also highlight here that in this case, the kind of publisher and the subscriber are different things. They're different devices. This isn't like a request and response. This isn't ping pong. You see a lot of ping pong benchmarks. This is a different type of beast. And I'll just mention that, yeah, I mean, obviously there's multiple of these types of scenarios running. I mean, you're not going to pay all that money for a private 5G network and then run one scenario, right? You might have dozens of these. I mean, who knows what you're going to have, right? But you can imagine the throughputs can go very high. And I'll just mention too, when I talk about latency, I guess, at least in this context, for whatever reason, a lot of people seem to like the P99 number. So, I mean, average latency is kind of meaningless when you talk about things crashing into each other. It's like on average, if they don't crash, but then some of the time they do, that's bad, So P99, for people that don't know, it just means 99.99% of your latencies are better than that number. So you can talk about more nines than that if you want, but that's kind of how I thought about it. Yeah, so that's kind of I know it's kind of a lot of numbers and technical jargon, but yeah, any questions there?
No, I was just going to say, like, if you want to if you want to talk about the scenario with cars, the West Coast, Los Angeles, probably a lot more cars than New York City, right? Because everybody in California drives. Yeah, no, I mean this makes absolute sense to me. I mean,
Oh, okay.
in the way networking is like exploding. Like I got a new car like 2 years ago, and there's so many sensors on it, right? You can track it with your phone and all that stuff, and like that's how everything is moving to that direction, right? So I would expect that this kind of scenario is only going to proliferate, and the numbers are going to be even larger before we know it.
Yep. Cool.
Awesome.
All right.
Okay,
and
yeah.
I mentioned at the top, yeah. So this is sometimes people call this an IFTTT scenario. If this, then that. It's a pretty common scenario in IoT. There's a lot of these types of scenarios. You can imagine hundreds of them. So I just picked one here. All right. So yeah, diving into kind of what I faced. So again, I was sort of given this use case at a high level in a business context. I was asked, go figure out how to do this. I mean, so again, you can kind of use this, the previous slide as kind of a proxy for what I had to actually think through. And yeah, so these are my options, right? So at my company, we had a ton of legacy C++ code. And this kind of goes back to the comment about Java, right? So, I mean, as much as I don't like Java, I mean, I like C++ even worse, right? And that was sort of like, I mean, it's kind of like, I think Winston Churchill said that democracy is the worst form of government except all the other forms of government, right? So that's exactly kind of what I was getting at. So I can tell you at my company, we had sunk tens of millions into C++ development, and just at a high level, the business was not happy. They were not happy with the productivity. Could be a bunch of reasons for that. Again, I'm not trying to make some sweeping judgment of C++ here, but I think it should be discussed. I think sometimes people say, why would you ever use Java for high throughput, low latency? I mean, to me, that's going too far. I get that C++ is faster, but I mean, that's only one kind of part of the equation. So I put a link there to somebody else kind of mentioning some things. We can talk more about that if it's interesting. So we were actually moving to Golang from C++. So there's a lot of Golang development, which I think even Google said that they didn't like C++. So they invented a language to get away from it, right? Because it was killing them. So I mean, that makes me think there is something to switching to some of these other languages. So Golang was an option for me. A lot of Spring Boot, so that was an option. But yeah, just right from the get-go, when I saw the performance requirements, which again, I'm not sharing today the detailed performance requirements. I'm just giving like kind of a high level so people can think about it. I mean, yeah, right away, I'm thinking Spring Boot's not going to work for this, right? I mean, and a number of people said that. Don't even try. Like, you're just going to get killed here if you propose that. So that was,
yeah. Question before I don't think you mentioned it, or if you do, I missed it. But what kind of machines are actually deployed on these like 5G edge networks? Are these like powerful machines? Are they like small? Because obviously, like the how much throughput you can get from an application depends on what you're deploying on, right?
No, they're power. Yeah, so these are, I mean, these are new deployments. So if a customer bought a 5G network today, I mean, they're mostly like, your commodity like x86, blade servers, but they're going to be whatever the latest thing is. So they're not like, it's not like super specialized high performance compute type hardware, but kind of the best you can afford, probably commodity hardware, if that makes sense. So I mean, pretty powerful.
That makes absolute sense. Yeah, I think that sums it up greatly. Yeah.
Okay. And when I did my testing, I mean, I'll mention some of the performance testing I did. So I actually bought like you could say like a private cloud setup. I bought that. I put it in the lab. That's how I did my testing. So yeah, I mean, the hardware was very fast. So yeah. So anyway, so my options. Spring Boot wasn't really an option. So, and people had mentioned to me this thing, Project Reactor. I think some people just call it Spring Reactor, kind of the analogous thing to Quarkus, I guess, maybe, or, Quarkus's reactive approach. So that was on my radar, certainly from the beginning. Golang, obviously, a lot of people just told me anecdotally. I saw on the internet, it's faster than Spring Boot at least. So that was an option. And then, of course, a lot of people talk about Vertex being just having a really great reputation for performance, being around forever, withstanding the test of time, all of this. So that was on my radar. And then, yeah, actually, I found out about Quarkus kind of just by Googling Vertex, right? So I wasn't really looking for Quarkus. I just found it by Googling, high performance Java and stuff like that, low latency Java, and just kind of stumbled onto it. But I'll talk more about why, obviously, it was so interesting. So yeah, so at a high level, these were the options that I was trying to. I mean, so like I said, there's other obviously Java frameworks. We can talk about that. I'm just trying to, for the sake of time, get to the most interesting comparison, I would say.
Excellent. Yeah.
All right. So my next slide, I won't spend a lot of time on this. Maybe we can come back to this if it's interesting. But some people told me, don't worry about it. Just pick something. It'll be fine. There's kind of this attitude I've encountered in some engineers. So I don't know if it's helpful, but I do think maybe it's helpful to talk about why this is a hard decision, right? Picking something like, moving to Vertex, Quarkus, whatever it is, right? Even Golang from Spring Boot. And I don't know the best way to say it in a succinct, short amount of time, but basically, I'll tell you. I'll just tell you what happens to me personally if I get this decision wrong. So if I go to my business and say, okay, great, I heard your requirement, low latency, cool. I'm going to use Quarkus or whatever, right? Give me, $5 million, $10 million, something. I'm going to go build this. I'll show you a great product in a year, whatever it is. If I do that and get 3 to 6 months into the project and realize, oh wait, Quarkus is a terrible framework, I don't get to go back to my business counterparts and say, sorry, I made the wrong decision. I picked this thing called Quarkus. I thought it was cool, but actually it wasn't. It's really hard to work with. So now I'm going to have to switch to Golang. That's not a conversation I can have. I mean, I probably get fired if I said that, So what actually happens in reality, and I have seen this happen multiple times, is if you make a bad decision, because again, this wasn't an academic exercise. I don't know if I said that, but I mean, I had to pick something and then I had to actually scale a team and build it. It wasn't like I could just recommend it and okay, I'm out of here, have fun, right? I had to build this thing. So if I get halfway into the project or 6 months, whatever it is, and I made the wrong decision, I mean, I've seen this. It can be very painful. You're stuck with something that you don't like. It's hard to use. Maybe it's hampering your productivity. Maybe there's bugs. It can be a real nightmare. And I think, honestly, a lot of people tend to be conservative on these decisions. I think that's a real reason why people kind of feel like Spring Boot or whatever is a safe choice. It's sort of, you're not going to have this issue. So yeah, it can be bad, and I can tell stories if we have time later about even just bad technology decisions I've seen made and how painful it was, But I think that's probably enough on this. We could, for the sake of time, keep moving. Or any questions, comments on kind of why
I just wanted to
using Quarkus was hard?
Yeah, we have a comment that's pretty much sums this up. From the user's perspective, that Spring Boot for Douglas says that Spring Boot for high load performance related workloads is just a non-starter. I wish more Spring devs would understand this, despite some apparent convenience of Spring Boot. Yeah. So what I wanted to summarize from what you said is that a lot of developers are in a scenario where there's typical microservices. You might not have a ton of customers or whatever. It might just be a small part of the system. So that in those cases, pretty much whatever you choose will work, right? You could choose Ruby on Rails, you could choose Node.js, anything will work, right? But in scenarios where like the ones you're mentioning, where things are super expensive and they're really performance really counts, and a lot of people don't have the experience to make decisions under those kind of conditions, right?
I would include myself in that category. I mean, it was definitely a hope and a prayer, right, that this would work. So, yeah.
And thank you, Douglas, for being a fan. Excellent. Cool. Thanks.
Yep.
All right.
Let's move on. So digging into it. So again, just to kind of broaden the scope, I mean, again, this isn't meant to be some rigorous technical analysis of Quarkus. This is just me saying at a high level, trying to make this decision. Obviously, I care a lot about performance. I specifically cared about this kind of pub sub latency, not so much. I mean, I had REST APIs. I had some cron jobs that were running. I had different types of things happening. But I mean, yes, the burning thing was that kind of scenario I talked about. Obviously, very concerned about team productivity because, at least for me, working for a large enterprise, I mean, maybe people experience this universally, but typically, you know, for a new project, I'm given not enough money and way too many requirements, right? I mean, I've never seen it the other way around. I did work in, you know, like more of an academic environment, and it was kind of the other way around, and that was wonderful. But yeah, in the real world, so yeah, productivity is a big deal, right? I mean, if I improve the performance by 10x, but the team productivity goes down by half, that's not really an acceptable outcome, I would say. I would actually rather just go back to the business and say, sorry, I can't do it. You know, I mean, just being honest. So I have this category called being enterprise ready. It's just kind of a bit of a hodgepodge, different things that matter, maybe that don't matter so much for people doing their little one-off project. And then there's this, I don't know what to call this, extensibility. It is a unique feature, I would say, to Quarkus that I'm not sure people have thought about, all the different protocol supports through Vertex. And I thought I would just mention that as a huge plus. And also the integration with things like Camel and the larger kind of micro-profile ecosystem. I thought I would talk about why that mattered to me. So again, maybe not as important as the performance, but I'm trying to, I guess, take a well-rounded look at things and explain kind of why I liked Quarkus. Does that make sense?
Absolutely.
All right. And I'm not sure we'll get through all this, so we'll kind of take it, you know, whatever's most interesting and most important. But we'll dive into the performance side. So yeah, a lot of information here. And I don't know if you want me to just say the performance results. You know, again, this isn't like a talk on performance testing, how to analyze performance numbers. But as you might imagine, you know, Vertex and Quarkus actually were pretty close together, I would say, in performance for my my particular use case.
That's been a goal of ours, right? To be as close to Vertex as possible.
Sure.
And if again, we are faster, something is wrong in the
right. Then again, I'm talking specifically about that scenario I already mentioned. I'm not talking about 10 different tests or some, you know, extensive benchmark. But yeah, I mean, and so again, it was much faster than Golang. I mean, I don't know how much to go into numbers, but and obviously, like, it crushed Spring Boot. So, so yeah, I mean, the performance was great, and you know, very happy about that. I will mention that sometimes people talk about performance in this kind of academic sense of like, who's the best? How much better are you? I mean, so just as a reality check, in the real world, nobody cares. You know, like nobody, at least in my business side, comes to me and says, you need to pick the fastest framework on the planet, right? I mean, that's not how these things go, right? They have some requirement, they want you to meet it. And yeah, Quarkus did well. So I would say it was extremely time consuming to do that testing, to do that evaluation, to do all the research, to try to figure out, is Quarkus even good? So, I mean, this is kind of some, I guess you could say, some feedback or some input to the team just on just the challenge of trying to make sense of all of these concepts. Again, I guess I wouldn't say I'm an expert on any of these concepts really. So I'm hoping other people can explain them better, you know? So, I mean, a couple of things. One thing is having some kind of a benchmark that doesn't test HTTP, you know, database stuff would be great. And I saw that there's this benchmark called Open Messaging. It's actually pretty interesting because it came from the Pulsar team, I believe. So they were trying to get market share from Kafka, I believe. So they came up with a whole benchmark and you know, showed that they were better than Kafka. Of course, Confluent came back and said the benchmark was wrong, and there was some good discussion. But yeah, having something like this would be super helpful because, I mean, again, maybe it's obvious, but setting up these types of tests is very time consuming. I mean, I had to build a whole load testing framework. I had to do all this stuff. And then, so that's part of it. The other part is just trying to understand the concepts. And maybe people have already alluded to this. Understanding why is async non-blocking faster? I mean, I would think that maybe that's a hard thing to explain. Maybe it's an easy thing. I don't know that I really understand it. I know that I put a link to a presentation from Netflix that showed a lot of really interesting kind of low-level Linux kernel like data that are kind of explaining what's happening. And it seems to me that's maybe where you need to look to really understand the difference. But again, I don't have any idea how to get, like, they're talking about, like, you know, processing time per instruction and things like this. Like, I don't know how to get that, to be honest, and pull that into some kind of a report that I can analyze, or even how to analyze it. So I think, yeah, if there was more discussion at that level, it would be super helpful to people like me, just trying to understand. I mean, again, I don't necessarily believe people when they say, oh, try this, it's better. I mean, I kind of want an explanation why as an engineer. So there were other things that bothered me too, like in the Vertex world, for example, they just kind of say, we use 2 event loops per core. It's great. And it's kind of like, is that not correct? Is it not 2 anymore?
Not true anymore. Yeah.
Oh, I know they changed it. Okay, maybe this is when I was doing it. What is it now?
Maybe the doc has not been updated, but
okay.
Initially that's what brings us best performances is choose thread per core because of hyper-threading. So basically your core is abused by the operating system and you can do 2 things. Now we found out that with the latest generation of CPU cores, it's better to have just 1 per core. It's what gives us the best performance.
Oh, okay, interesting. Okay. Well, that's interesting. Yeah.
Things are not written in stone. It's evolved over time based on technology and so on. But yeah, the true reason why I think is generally better than Sync is mostly hardware, operating systems, and how these things are actually working in today's. And everything you make blocking on top of that is actually making it convenient for the developer, not for the operating system. But there is a lot of objects, time, garbage in general that need to be created to make it easy for the developer. That's the reason. You pay that cost.
Right.
But yeah, I can write actually about that in more detail than this.
I'm not saying you should write about it. Maybe there's somebody watching who will be inspired,
Clément loves to write stuff, and he's really good at it. He spends a lot of time on these little diagrams that are excellent. So yeah, I mean, I'm sure he'd be glad to do it.
Okay. Yeah, that one, as you say, would be very, very useful because for me it's okay. I know it, but yeah, maybe I need to explain to everyone why it's actually done like that and why Quarkus reactive core give this performance benefits that we will be talking later.
Well, and again, if you can back it up with data, like thread migrations, time for instruction, that's I think very compelling to be like, and even if you can do the comparison with Spring Boot or something, that's, you can't really debate that, I guess. I guess you can say the test is wrong, but so no, that's interesting. Yeah, so the event loop thing, because I thought it was 2 event loops per thread when I looked, but I remember thinking like, why did you test it? Is there data? And probably it sounds like there's this new C++ framework called C Star. They're big on the thread per core model, so it sounds like maybe Vertex is kind of normalized on that. But yeah, just seeing the discussion around that to me gives me confidence that the people behind these frameworks kind of know more than I do, right? And have really thought it through. So the other question that came up was about garbage. So I don't know if you guys have heard this. There's some company behind this product, Coral Reactor. They claim that because of garbage creation, you'll never get good latencies with Java. I saw another link from InfluxDB, similar claim. I have no idea if that claim is correct. I don't even know how to test that, but I don't know if that's an interesting thing or not, but it'd be great to have somebody speak to that. And because I don't know, it kind of just when I'm looking at these things, when someone says something like that, if you have a lot of garbage, it's bad. It kind of makes me worried, right? Like, oh, okay, well, should I be going with Quarkus if it creates a lot of garbage?
So when they say that, it's mostly the cost of a garbage collector. The thing is that garbage collector has improved a lot recently. Most of their saying are based on the serial garbage collector, which I will be fair, is not the most performant thing. But now with Parallel and even Shenandoah and things like that, things have improved a lot. And I will not. Java is not slow, and actually France, which is not there unfortunately today, has done amazing analysis and measurement to explain that actually we can be very, very fast. And even on Tank Power, okay, it's not messaging, it's HTTP. You can see that Java framework are actually performing quite well now. And Gunnar Merling last year did something called the 1 billion row challenge, which is basically in Java, how can you read and do stuff on a document which contains 1 billion rows, so very large data.
Yeah.
And when you see the results, okay, you have the regular results and you have the magician results, which are abusing everything to make it fast. But, but if you really look at regular human things that a human can understand,
readable Java.
Readable Java, you will say, whoa.
Yeah,
actually,
damn fast,
it can be super fast. So
yeah,
I will recommend you to check the 1 billion row challenge. That was last year, and it was crazy.
Okay. Yeah. Cool. And then the last thing I'll mention. So actually I didn't mention it, but I talked to a lot of vendors also because I had to find sort of a vendor solution that could try to achieve these low latencies. And one vendor did tell me that if you're not using the LMAX disruptor, you're not going to achieve low latency with Java. So I think there's maybe other people that believe that. So that's another kind of interesting thing to. I would love to see kind of a rebuttal, from Vertex, Quarkus. Hey, here's the disruptor pattern. Here's why it's great. But actually, I can tell you in my testing, at least the vendor that was using LMAX disruptor did very badly on the end-to-end latency, right? So they're in like kind of once the message had been processed or whatever, they could achieve very high performance. So they kind of had this benchmark that was very misleading, and I had to really dig into it. I was like, oh wow, this actually is not what I care about. So I don't know. I mean, that just kind of highlights that. I mean, there's these different concepts floating around. It can be confusing. I mean, for me, it was confusing trying to make sense of all these, trying to know what's real, how they're all related. So that's why I kind of mentioned that if there's more guides, more explanation from smart people, I think it actually benefits Quarkus and.
Yeah, so what I take out of this is that we need to do more writing, more explaining.
Well, you don't need to. I'm just saying, it might help your cause, No,
well, that's exactly it. That we, apart from like developing features, like a real struggle, let's say, is getting the proper message out, right, and getting it to stick. So no, this is great feedback. Cool.
Okay.
All right. We only have like a little more than 10 minutes, so
so we keep going.
Yeah.
Well, let me just mention one more thing briefly, just to give you guys an idea. So one pretty crazy thing you can do with Quarkus, maybe you haven't even thought of this, is it has support for Vertex has support for the MQTT protocol, which is used heavily in IoT, and typically it's used in kind of low throughput, I would say high concurrency scenarios. But that was one of those things for like an embedded scenario. So what I did is I actually ran Quarkus on a Raspberry Pi, and I actually implemented like an MQTT endpoint. I wouldn't say it was a full broker, but it did that kind of input-output type benchmark that I was talking about, and it was incredibly fast. It was very, very fast. So I mean, I think it would be a shocking result to people to know that that's even possible, right? To run Quarkus on a like a smaller, board or whatever, and get very good throughput. I don't know. It's kind of a cool end-to-end scenario. So I'll throw that out there since I mentioned the embedded stuff earlier. But we'll keep going here. I'll skip talking about extensibility for now. I'll even come back to the enterprise-ready stuff. Let me talk about the team productivity. We'll go to that. So I think that's the next most important thing. So, because again, I think this is something, part of why I wanted to do this is I looked at a bunch of existing guides on, Spring Boot versus Quarkus, or, Spring versus Vertex or whatever. A lot of people seem to miss the point in my view. So I wanted to call out what I think is kind of the most important concerns, at least for me. I mean, hopefully other people, but this team productivity is a big one, right? So, and I see a lot of people say that, moving to this reactive approach really killed their productivity. It made the code less readable. Code was harder to write. I think it's probably the most significant argument against that approach. I know Quarkus kind of unifies imperative, reactive, whatever. So this is something where I'll just, again, say for me, getting into it, it was very overwhelming to try to make sense of all these different approaches to concurrency, and to understand, again, not from an academic standpoint, but to try to figure out what happens when I move my team of 10 people, let's say, from something they're familiar with. Like, let's say they're familiar with the kind of completable future approach. If I move them to reactive, what's the productivity hit going to be? So that was kind of a challenge for me. And I did see that there was the hit was hard to quantify because some people seem to really understand it and some people really struggled. And I'll definitely say that once you move to, a lot of people, I think when they imagine these async kind of scenarios, it's, again, kind of simple stuff like async HTTP into async like database. Those I don't think are particularly difficult. I'm not sure it superly matters what paradigm you adopt, but once it gets into like the more complicated stuff like async action one into like a for loop over the results into like some other async actions. So I love the phrase from Clement's. I put the link to his superhero presentation here because he uses this phrase, something like, it's a jungle out there. When you get into these RX Java type complicated scenarios, map reduce. I definitely have seen that. And I've seen that even with Quarkus, to be honest, because I think that you can certainly make a mess of things very quickly and have code that's functional, but not readable. So I think, there is room for more discussion around how do you write complicated composed asynchronous stuff. I don't know that we need more discussion about how to do the database thing. That seems like that's covered, but so yeah, I just wanted to put that out there that was a challenge. And there was other confusion too for me. Like a lot of people said, well, you're moving to a functional style if you move to reactive. It seems like there's some confusion between people. Is it functional? Is it not? If it is functional, what about immutability? I don't think I saw anybody talk about that really. And another question too is a lot of people say, well, by moving to a functional style, I actually increased my productivity. Because some people, but there's a lot of just, I don't know. I don't know if somebody can explain that better. It would be helpful if they could. That makes sense?
It makes sense. It's the functional style has been there for 60 years now, and there are trends right now. It's not the main trend, but I can't say that it's really for everyone. Clearly, it's hard to make to take a problem that is described as a flow or a set of action or a for loop or something like that, and then try to map it to a functional style programming. That can be pretty hard, actually. It's not necessarily natural when you try to represent something from the real world. Sometimes it works very well, but sometimes it's slightly more complicated.
Yeah.
And actually, I think the jungle was about the flat map stuff, but I believe people don't really. That's typically they don't necessarily understand flat map correctly. So
flat map specifically. Okay, I thought it was kind of like RX Java, like
it's
general.
the whole thing, but
the whole thing is kind of a jungle, right?
Yeah. Clearly.
Yeah.
Julien Ponge has a very nice a slide where he shows some code from his book he wrote, and he took it. It was using RX Java, and he took it 6 months later. He was like, I have no idea what it is doing.
Right.
He wrote the book, so okay. So that's that can be complicated.
Yeah. All right. Well, let me make a few concluding remarks here. Then I think I have some random. Here's my random comments on kind of how everything stacked up, just to kind of close things out. So yeah, I would say the Project Reactor, Spring Reactor, to me was pretty disappointing. Again, I'm not backing this up with a lot of data, but given how popular and how extensive Spring Boot is, I would say, and what it offers, Project Reactor felt like almost a completely different project to me, completely disconnected. The documentation, the quality, The number of integrations, I didn't get to talk about that. Even the performance to me was bad in my testing. And I think in Tech and Power at the time, I went back and couldn't even find this, but the Tech and Power numbers were bad. There were just so many things about it that were just really puzzling. I don't know if that's just me, but I actually had somebody do a spike on it. We actually implemented like a small microservice using Webflux. And even that was very difficult for that person. And it just wasn't a good sign. I don't know if that was the documentation or the composition or what. So yeah, I would say, Mutiny is a huge win for kind of the async composition reactive world. I mean, I didn't try RX Java, but even just reading about it gave me a lot of anxiety, to be honest, and just felt like I kind of get why maybe it's needed on the front end, but it just felt like so much complexity for what I was trying to do. So yeah, I think Mutiny is a huge win. I think, if there was a for loop in Mutiny, like there is, I don't know if I've not understood it correctly, but in the Python JavaScript world, I believe there's like an async for loop. That tends to look very messy in my view, I guess, using Mutiny. So I just kind of make that as I know we're out of time. So I'm sorry to just kind of throw things out there.
Yeah, do it.
But that's an area where the for loops could be a real nightmare. One thing that'd be super helpful to understand is just what is the syntactical difference between Spring and Quarkus? Because I think it seems like a lot of stuff is actually pretty similar as far as the annotations and things like that. But if there was like a clear, and I know there's even like an automated migration tool, but to just even understand like how bad is it really? I mean, maybe it's actually not that bad to take a Spring Boot project and go to Quarkus or go back again. And then on Golang, I'll just say Golang to me is kind of this like kind of weird middle of the road solution because it's better performance, say, than Spring Boot, but it's not like amazing performance. So it's kind of like this weird in between. I would say, syntactically, I mean, the way they handle concurrency using coroutines is, I'd say, pretty nice for a lot of people. I've seen a lot of people use it, really grasp it. So it's like it's definitely adding something, but I'm not sure how much it's adding in these more performance constrained situations. So that's kind of how I thought about everything. Reactor, kind of was out for the reasons I said. Golang kind of maybe would have been better, but not great. And then I'll just say for Vertex, I mean, I had a lot of trouble understanding how you would use Vertex to build an application. So, I mean, to me, I kind of think of Quarkus as like, it's basically, Vertex plus, dependency injection and the composition. It basically makes it usable. I don't know if I just didn't understand it well, but,
I completely agree with you because I came to Quarkus from like a Spring world, and Vertex does some amazing things. But whenever I've like had to do like try to actually build something with Quarkus, I almost always with Vertex, I almost always just end up ditching the plain Vertex project and using Quarkus to put everything together and then use Vertex. Because like the other day, I couldn't even get logging to work. I just couldn't get logging to work with plain Vertex. I spent like 15 minutes. It didn't work. So I'm like, I throw it out. I'll just build a project with Quarkus and Vertex, and everything just works. And then I just write my handlers and.
It's because I did the integration of the logging of Vertex with the Quarkus logging. That's why.
Yeah, it's good. The logging is great. The logging is very good.
Yeah, the point is that like just Quarkus like puts all the parts.
It puts it together,
so you can just work. Yeah, exactly. Yeah.
The thing is, so Jonas comes from the Spring world. I come from the Vertex world. So it's like it's actually funny. Vertex is a toolkit. It's a library. You need to do everything by yourself. It will not take any decision for you. So you have all the power, but you need to do things correctly. Quarkus is really a framework where we take some opinions. We say it needs to be done like this. Logging is this. While Vertex will say, no, logging, well, you can do that, or you can do that, or you can do that, or you can even implement your own. That's not things we allowed in Quarkus, because in Quarkus we are trying to be way more directive. Sometimes not enough, sometimes too much. It's hard to find the right balance. But it's toolkit versus framework. So
Yeah.
Not
absolutely.
well. Both have use cases, but yeah, for your case where you have a team behind you where you need productivity, frameworks are generally better suited.
Yeah. Yeah, but I guess I'm
Yes.
not sure what framework you can even use Vertex with other than Quarkus. Maybe
we had a few over the past few years, but yeah, Quarkus is the main one.
that's the challenge, right? Yeah, is like, yeah, maybe it's behind the scenes, but yeah.
I've seen, so typically there is a couple of API gateways that are using Vertex underneath for the concurrency part and reactive part. There is this, I don't know if we can call that a framework, but Restate, which is a way to build distributed system. And the Java support is implemented with Vertex. There is a few things like that. But yeah, as a main or mass market framework, no, Quarkus is one of the is really the only one that is pushing or fully based on Vertex. But it's relatively easy, as I come from the Vertex team. We still work closely with the Vertex team, so we know when we know what needs to happen and how things work.
Yeah. Cool.
Very nice. Very nice. So any concluding remarks? I'll just say that this was amazing. For me, it like gives a totally new perspective that I didn't have. So very
on the domain and on the selection criteria, like as you said, you have a new project with plenty of requirements. Which framework, which approach will you use? And that your characterization framework was quite interesting, and even better as you pick Quarkus at the end. But
yeah. Well, no, I would just kind of in conclusion, what I would say is when I Googled, I put this kind of last slide, I think. When I Google like Quarkus versus whatever, right? A lot of people just say like, oh well, HTTP is better. Look at memory usage, startup time. A lot of people say it depends on what you want to use. I mean, just pick whatever. I mean, I don't know. It just feels like that kind of misses the point. I mean, in my case, it didn't depend. I mean, I couldn't use like Spring Boot, So, I mean, I guess, like for your side project,
your job depended on it.
I know. So that's the thing is like, I hope, there'll be more discussion. Maybe we can work together on a blog post or something, but maybe getting more into the actual criteria people face in the field. Because I think actually Quarkus, there's a lot more to it than just memory usage and startup time. I'm sure that's great, but like, there's a lot there. So and Mutiny in particular, I'll just again say like that was really surprising. I did not expect. I thought I was stuck with RX Java. I thought this is really going to be a problem. So I mean, there's I don't know. There's almost like so much there with Quarkus. It's hard to know how to even explain it all. But I really appreciate everything you guys have done. It certainly helped me, and my project worked out well. I mean, just you probably already guessed that, but people were very impressed with the performance. The productivity. There were some challenges, but I mean, definitely better than it could have been. So, overall it worked out. It was a big win for me. Yeah.
Oh, that's great to hear. I mean, it's great, like after explaining all the challenges and then coming to the conclusion that it worked. Like obviously, there are things that could be improved, and we can discuss it more and like perhaps the blog post you mentioned too. But coming to the conclusion that this was a very successful project. That's great. That's what we want to hear.
Yep.
Oh, thank you for this feedback. And sure, there's plenty of things we can improve, and we will. Just take times and And Thomas said something in the chat that at TechCompo, lots of Java framework are actually using Vertex for the database access. Even frameworks that says that it's not the right things to do, but funny story, things like that. But well, because it's when you need to reach a certain level of performance, especially in terms of concurrency, at some point you need to go back to what the operating systems do the best, and yes, that is going to change a little bit how you do things. But if you want to reach that level of performance, you have to pay that cost. However, at the same time, if you don't need that level of performance, stay away. Like,
But I'll also mention one last thing. Like the future is even better because like operating systems with things like IO Uring and Quarkus and Vertex being able to leverage stuff like IO Uring, that'll hopefully take stuff to another level. And like in the medium to long term, right? This isn't like now, but yeah, things will be even better.
well, you can already use IOUing with
Yeah,
Quarkus
sure, but I
right
mean,
now.
yeah, but you need like a very latest kernel because they love bug fix and stuff like that. But anyway, yeah, there's a journey.
Yeah, there is. Yeah, but yeah, the test we have made with IOUing has been amazing. Like it's crazy. Well, it always depends on your use case, of course. Depends on what you do, but yeah, the tests we have done are just fantastic. So yes, and without Vertex and Netty and things like that, we will be years away of using that kind of techniques.
Absolutely. Yep. Cool. So let's keep in touch and
yeah, thank you, Charlie.
Best of luck for your job search.
That's right. I was supposed to mention, I'd love to work at Red Hat. So, if anybody's watching, hit me up for sure,
Cool. Let's hope that can happen.
Yep.